Ellie, have you considered talking to Dr. Becky? Ellie, I suggest you interview Dr. Becky. Ellie, have you considered reaching out to Dr. Becky? Yes. Yes. So many of you guys have asked me to interview Dr. Becky, and of course I wanted to. So I reached out to her and got this awesome interview. I had so much fun talking to her. It makes me want to hang out with her in person. In case you're not familiar with Dr. Becky, she is a junior research fellow at the University of Oxford. She's won awards for her work, and she studies the role of supermassive black holes in inhibiting different types of galaxies from forming stars. She has her own YouTube channel. Many of you guys are subscribed to her already, and she's also written a popular science book called Space 10 Things You Should Know. So let's just get straight into the conversation and learn a little bit more about our favorite, Dr. Becky.
5, 4, 3, 2, 1, 0.
First of all, I want to thank you for agreeing to come on to my channel. I have had a lot of people suggest that I interview you, so thank you for answering my email. And let's start a little bit telling me about how you got into physics.
I was the kid that was obsessed with space and would tell every single person I came across that I was obsessed with space. I remember getting a book, whether for a birthday or a Christmas or something, it was like a fact file about all the planets, and it just had the most gorgeous images from the Hubble Space Telescope, and then there'd be a little sort of like table with all of like, you know, like how long does the planet take to go around the sun, and like how big is it compared to Earth and everything. And I was just obsessed with it. And I, you know, then from then on, like I wanted a telescope rather than a bike for Christmas, you know, that kind of thing. I think going forward, I didn't realize at that age, like, you know, 8, 9, that you could do that as a job.
Right.
You know, I think in the next couple of years, I then got obsessed with dolphins. And then I realized that scientist was a job. And I went around telling everybody that I wanted to be a marine biologist.
Yeah.
And then we started doing astronomy at school when I was about 15, 16. And I realized, oh, this is part of science, this thing that I absolutely love. And this is something I can do. And so at that point, you know, I mean, in the UK, we pick our subjects. We only do 4 subjects for 17 and 18, like last 2 years of high school. Wow. So at 16, I was like, I want to do physics. I want to do maths. I want to do even harder maths. I want to do chemistry. I want to do all the science and the maths. And then applied to do physics with astronomy at university as well, with just sort of like no knowledge of where I was going to go after that. Just that if I picked a subject that I loved, it would in theory lead to a job that I loved as well. And then here we are.
Wow.
I'm an astrophysicist today.
That's amazing. And so impressive. Was that something that came easy to you once you decided you wanted to focus on that?
I think so. Yeah, I still am. I'm very stubborn. Once I made my mind about something, no one can really change it. Very sort of bullheaded and I remember just sort of telling my parents that that was what I was going to study. There was no discussion. Like there was no, oh, what should I do? Help me. I was like, I'm going to go do physics and astronomy. And so I think once I'd set my mind to it, I was just like, that's me.
I guess I meant like, are you inherently good at like maths and sciences?
I think maths, I've always enjoyed it. So maths is the language we use to do a lot of physics. So that helps the fact that I at least enjoyed that side. I didn't always get it right. Like I remember learning something in maths once, which was like expanding like the brackets into a quadratic equation. Like we used to call it FOIL. I think there's a different name in the US, but in the UK we called it FOIL because it's like first, outer, inner, last, and people probably know what I'm talking about now. I said that, and I remember learning about that when I was like 14 and just not getting it at all. I remember just like crying because I couldn't get it. So there's always been areas that like I've not been good at. Like I was terrible at electromagnetism when I was at a physics undergrad. Like anything that we did about electricity or magnetism, I would be like, I had to like sit down and be like, what is going on here? It didn't, you know, come as sort of like fluently as the astronomy side of stuff did necessarily.
Right.
But I think it just helps that you enjoy it. I think if you enjoy something and you have a passion for something, then even if that subject is considered hard or difficult, you're willing to put in the time to understand it. And so that's what I did.
That is so cool. And tell me a little bit about, you know, your education path after that and your career path. I know there's a Wikipedia, but I want to hear it from you.
It still weirds me out that I have a Wikipedia now. My friends, I didn't tell anybody that when that happened, my friends like sent it on the WhatsApp group, like, what is this? Yeah, so I obviously did physics and maths at school. I did an undergraduate degree at Durham in physics and astronomy. So that was like a 4-year master's. So you get your master's before graduating by doing that in the UK. And then I actually didn't know what I wanted to do after that. And all of my friends were applying to graduate schemes. And I was like, I want to work in like the space industry, I think, because that's the only like job I knew about really at the time. That, you know, I tried a bit of research in my 4th year, but I didn't just want to do a PhD because I was like, I don't know what else is out there. So I was trying to apply for places like Astrium and like Surrey Satellites in the UK that are like sort of satellite tech people. And I didn't get into any of them. I got rejected from all of the things that I applied for, except for a few grad schemes, which these ones where it's like, we'll hire you for 2 years fresh out of university and we'll mold you to what we like. And it was with Rolls-Royce, which is, they don't make cars, they make plane engines. And I figured, how far away is a plane engine from like a rocket launching a satellite?
Yeah.
And I was like, at least I'll get experience in like the engineering field side of things since I've done a physics degree. And I got there and it just wasn't for me. I could see all these other people around me that were having the best time ever. And I was just like, I am miserable. Like I miss like just talking about space all day. Right. And like I'm sat at this desk crunching data. I'd rather be sat at my desk crunching astronomy data than like what I was working on there to do with the jet engines and stuff. So I was only there for a year before I'd I was there for 3 months before I decided I was going to apply for a PhD, and then started the application process. And then a year after starting, I'd quit and started a PhD. And the PhD is the degree you obviously do to become an independent researcher, basically like forge out your own science path and realize what it is you want to work on. So that was then 3.5 years at Oxford with the Galaxy Zoo team. For everyone who's classified on the Galaxy Zoo website online, thank you. You made my PhD possible, classifying the shapes of galaxies. And then I did 2 years in Nottingham as what's called a postdoctoral researcher, as a fellow there. And then I'm now in my 4th year of a fellowship at Christchurch in Oxford. So back to Oxford. I really like it down here. I'm a northerner in the south, which is always good fun. But it's I absolutely love what I do, and like just having the freedom to do it. Like I can't explain how freeing academia is, especially being what's called a fellow, where like you're like, there's this pot of money available. You tell us what you want to do, and we will, pay your salary with that pot of money for you to do that research.
Right.
But like you're your own boss, basically. You're like you wake up and decide what you want to do that day.
Right. And you're not constrained by, financial worries. I mean, you can do whatever you want, which is awesome.
I mean, an academic salary is not that high,
Okay.
but like it's comfortable. Like it's over the average in the UK in terms of like, average salaries and stuff. So it's definitely comfortable. Like I own a house, for example, like we were able to put a house deposit down, that kind of thing. Me and my partner, but like,
I guess
in terms of like
for the research though, you get
the research is you get funding to like go to conferences in normal times and get the like electronic equipment you need, whether that's a laptop or whether that's anything for a lab if you were an experiment based person, or if you were running simulations and you needed access to like a big supercomputer or something like that, like all that funding is there. So
is it correct that most of your research has been about supermassive black holes?
I started off with a focus on galaxies, and I was trying to understand how stars stop forming in galaxies. And one of the main reasons that we still don't really have sort of like the smoking gun evidence that this is happening everywhere in the universe, whereas simulations say that it should be, is that black holes are causing this. So if you feed a black hole too much gas, it burps up. It's not from the black hole itself, it's from the surrounding regions of the black hole, but it sort of burps up a little bit of energy, and that energy then impacts the rest of the galaxy. It can, pick up gas that you would use to make stars and take it out of the galaxy, or it can heat up the gas so that then it can't collapse and form a star. So I can do lots of different things in theory anyway, but finding that evidence is sort of what I got distracted by in my PhD. And that's what's been my focus for the past sort of 5 years since then. And then also part of obviously understanding, okay, well, how does the black hole do this, is understanding how the black hole grows in the first place. Because if you throw too much gas in there and it ends up doing this sort of like burp from the surrounding regions, then why doesn't that gas make it in? And so that gets you into black hole growth. And so then I start wondering about, okay, well, how do black holes grow? Do they merge with other black holes? Is that what makes them super massive? When we talk, the black holes you find at the centers of galaxies are super massive. They are 1 million to tens of billions of times heavier than the sun, right? They are huge, but because space is just so mind-bogglingly big, like actually getting stuff to them is very difficult.
Right.
So, people have thought for a long time, merge two galaxies, you merge the black holes in the center, and that's what makes them grow. But then I've been looking at galaxies that have never had a merger, that have been left alone their entire lives, and the black hole has managed to grow just as large anyway. And so now I'm trying to explain, okay, well, how does that happen? And then can they still cause this sort of feedback effect through this sort of burp of energy through the galaxy as well? And so it's all sort of tied together. And I started off in galaxies and got distracted by black holes. So
how do you research and investigate that?
Yeah, you can't do experiments. Like the universe is our experiment essentially, and we just observe it, right? So there are clever things that you could do with telescopes to actually get at what's going on. So yes, you can't see the black hole itself because it's black. But actually when a black hole is growing, when it's taking in material, what happens is like a big clump of gas will come in. And like when you take, a ball of pizza dough and you set it spinning above your head, right? It flattens out into a disc. So you get this disc of material that's swirling around the black holes. And it's accelerated to huge speeds, like incredible speeds by the gravity of the black hole. So much that the gas actually starts to glow, like across visible light, X-rays, radio, everything, right? And they're actually some of the brightest objects in the universe, supermassive black holes, which is kind of odd thing that like people are like, what? That there's a black hole, but the gas around it is not sort of, that's beyond the event horizon, whatever, like it's not crossed that point of no return yet, is incredibly bright. And so you can actually observe the light from that gas. And what's clever is because that gas is swirling around the black hole, some of it's coming towards you and some of it's moving away from you. And so the light actually gets this Doppler shift to it. So the same way that like an ambulance, when it'll race past you and you'll hear the siren, change pitch, that's the wave sort of being squashed and stretched. Instead of a pitch change with light, you get a color change, like as it comes towards you, it gets bluer. And as it comes away from you, it gets redder. And so you can actually see that shift in the light that actually happens, because it's a very specific wavelength of light that's given off, because it's mostly hydrogen in that disk that's swirling around, and hydrogen gives off a very specific color of light. So you can see if that color changes at all. And if you know how fast the gas is moving, you know how big the thing is that it's moving around. And so you can, by observing this light, you can measure the mass of the black hole. And then the gas that's then, this like burp of energy that moves through the galaxy, that's got so much energy that it's enough to make not just hydrogen glow, but things like oxygen glow as well. And so if we can isolate just the wavelengths of light from the oxygen, you can see where these burps are having an impact as well. And then you can say, okay, well, how does that compare to how many stars are forming in that region, right? So like lots of stars usually means you have a very blue colored galaxy. Not very many stars forming usually means you have a very red colored galaxy, because newer stars are hotter, younger, bluer, and older stars are redder because they're cooler. And so you can sort of correlate these two things and look at what's actually happening in all your observations.
I feel like
everything together.
To the outside person, that's counterintuitive that the bluer stars are younger. You would think the redder stars would be hotter.
Yeah, you would, because that's like basically what like taps on sinks, right? Faucets have been telling us for our entire lives, right? It's red, it's hot, and blue, it's cold. But if you think about it like a Bunsen burner, right? In a lab, right, is bright blue flame. Yes. It's a much hotter flame than if you open the hole, and obviously then it's like a redder flame, right? Which is cooler. So actually in terms of like light given off by hot things, like think about like even if like you heat metal, right, it starts to glow and it glows like white, and then as it cools down, it glows with sort of that red color instead, right? That's what you've got to think about it in terms of heat, right? So that the youngest, biggest, hottest stars actually burn blue, and the oldest, smallest stars that are coolest burn red.
So that has been your focus for the past several years. Is that something that you plan to continue, for the next 5 years, or do you think that your focus will shift to something else?
It's funny you should ask that, because I've just been putting in fellowship applications again to be like, hey, my current fellowship runs out in a year, so I need more funding. I need my salary paying still, so I have to write a research application to say this is what I'm going to do for the next 3-5 years, and yeah, it's building on this even more. So it's specifically this sort of like growth aspect side of it, with this like, if there's not been a merger in a galaxy, how has the black hole grown? We're really trying to get at like what process is physically happening. And to do that, you need to limit like your sort of search field. You need to know, how much gas is being driven to the center. So you add up like, to find out what's going in, you add up everything that goes out, basically, because those are the things that you observe. So we're trying to like get better data. Like that's like a crisper, higher resolution, essentially trying to kind of say enhance on our data, if only that was possible, and to get better data with a different telescope and really pin this down. And so we can actually work out what's going on. And that's what I've been doing sort of for the past couple of months, intermittently, is sort of sending off applications. And a lot of my fellow postdocs and researchers will have been doing the same thing, because it happens at the same time every year. And it is a grind, but we keep going because we love what we do.
You must. What does it mean to reflect on, the fact that little Becky loved space and astronomy, and now, as an adult, you've won awards for your research? I mean, that is just so cool.
Yeah, I'm still, this was announced about 3 weeks ago, this award that I won for like the most promising research by a postdoc researcher in the UK. And I was like, in astronomy at least. And I was just like, I'm still processing the fact, like it still doesn't quite feel real. I think everybody suffers from imposter syndrome, and like, I do too. I'm still like, oh, what if I'm not good enough? Especially with all these applications going out and you get rejections and you get interviews and whatever. And you just think, oh, like, and then this award comes through and I'm like, what? And I don't think that 15-year-old me would have quite believed, just as I decided, oh, astronomy is the thing I want to do. Like, I don't think that I would have quite believed that could happen.
Right.
And that I could also like chat to people online about what I do as well. Like this, like it's a very odd concept. And there is this thing where, people have this weird misconception that like you can either be a good researcher or you can be a good communicator of science.
Right.
Like trying to be both here.
Right.
And so it's nice to be recognized for both.
Well, I think that can be a struggle for most people, right? Maybe if you're really good at research, and you're too technical with how you explain it, you lose your audience.
Sure.
you lose your people that don't understand what you're saying. So you obviously do a great job of breaking it down and helping.
I always say it's speaking a different language. Like when I speak to my colleagues, I'm speaking a completely different language to whether my mom like says to me, oh, like, what did you do today?
Yeah.
Like it's if I said to her the words that I say to my colleagues, like there would be complete like blank. So I've always, when I would chat about science, I've always got her in mind to see what like, oh, would she understand what I was saying, kind of thing.
Well, and of course, I'm trying to go in like order with the questions, but of course I want to talk about the YouTube and your growth and your evolution online. So when it looks like maybe, well, according to your Wikipedia, maybe in 2018 you started the channel.
So my first job out of PhD was at Nottingham, where they already have a very big physics YouTube channel called 60 Symbols. People will probably be familiar with it. And there's an astronomy related one that's called Deep Sky Objects as well, Deep Sky Videos. And the first job I got out of my PhD was a research fellowship, where it was like, yeah, tell us what research you want to do and we'll fund you for 2 years. Oh, but we also want you to make videos for 60 Symbols. So the application was like the normal stuff you get in a job application in research, which is like a research proposal, a CV, a list of all of the, science articles, publications you've made, and then a 2-minute video explaining something in physics, which is like most people I spoke to were like, that is my worst nightmare. Like, really? Put me on video or whatever. And I was like, this sounds fun, and like put it in thinking I'd never get it, and then did. So spent 2 years there making videos for that channel for 60 Symbols, stuff like, like in the Marvel universe, could Thor really have used a neutron star to forge like his new axe? Was there enough energy in a neutron star? That kind of stuff. It was really good fun. But then when that fellowship wrapped up after 2 years and I got my new post in Oxford, they were basically like, well, you know, it's Nottingham's channel, so we want to reflect the research that's going on at Nottingham. And I was like, okay, that, you know, that's completely understandable, but I've really enjoyed this like fun creative outlet. I mean, admittedly, what I was doing there was just coming up with the idea, and then someone would turn up, Brady Haran, for those who know him, and he would just film, and he'd go away and edit and post and do all that kind of like back end stuff for YouTube. And I was like, well, I'm going to miss coming up with ideas and chatting and stuff. So I'll just start my own, and I'll just learn how to edit and frame a shot and record audio and, you know, do all that kind of stuff on the job. Because that's how you learn stuff as a PhD student, right? You get thrown into academia knowing what you think is everything coming out of your undergrad degree. And then you realize you know absolutely nothing, and you just have to pick it up as you go. So I figured I'll do the same thing. And yeah, if you go back and look at those early videos I made in like October 2018, when I first started posting properly on my channel, like weekly, they're so bad. They're so blurred. The audio is terrible. There's like necklaces like clunking against microphones. Like it's like grainy, and like it's badly framed, and the editing isn't great. But I just picked it up on the job, and I learned the stuff that, you know, I didn't like about the videos I was making, and then just adapted it. And then slowly but surely, the channel just started growing. It wasn't like, you know, one video went viral or anything like that. It was just really slow and organic growth kind of thing, with the odd video doing, you know, a lot better than others, and people finding my channel. And just, I really like the fact that I can be, because I think there's a lot of people on YouTube making fantastic space content, myself included, right? But you might be like space journalists, you know, perhaps people who've done a physics degree and then are now making videos with their physics background knowledge. They're not doing research, so they, you know, they're sort of relaying information in that kind of way that they, like, I'd class them as like space journalists, and they're doing such a fantastic job of it as well, like in communicating and making the content and stuff. But like, I don't class myself as a space journalist. Like, I'm literally like, we've cut out the middleman here. Like, like I'm telling you like what I'm hearing from like working in research with all what my colleagues are discussing, why we think this is important, why we think this is cool, and just like relaying that. So like the tagline of the channel has always been like, your friendly neighborhood astrophysicist. Like, ask me stuff that you can't physically Google, because all you're going to get up is like scientific research articles that are written for other scientists.
So as an astrophysicist, I often get asked, what do you actually do all day? And I respond with, well, I try to answer questions that no one knows the answer to.
That is such a valuable and, you know, unique perspective to have for all of us on the outside.
Yeah, I'm just glad people enjoy it. Like, it's one of those things, again, if you told me at 15 that people wanted to watch my videos and stuff, I probably wouldn't have believed it, because, you know, like I probably was bullied at school. I didn't think I was at the time. I was just like, I'm great, but you all think I'm whatever, but I don't think you're very good, whatever. I was bullied because I was a nerd. Like, and so like, if you told me then that many people wanted to talk space with me, I wouldn't have believed you, because like, you know, nobody did at that age and whatever. So,
jokes on them.
Well, yeah, I'm still a nerd, but look at me now.
Yes, I love it. I love it. Yeah, I mean, your channel is pretty dang big. You know, I started really seriously making videos for my channel about a year ago, and now I'm at like 30,000, but you're at like, you know, over 360,000.
Something like that. Yeah.
Yeah. Is that just like, that's, you know,
but it's organic growth. Like, you know, you said it took you a year. Like, I was probably around about that level after a year as well. I think I hit 100,000 after 18 months.
Wow.
Because it just sort of, I think it was sort of exponential at the beginning, and then it was sort of linear after that. And it's just really, yeah, linear growth. I think it's just, you know, consistent posting, people coming back, people wanting to hear more. And like, you'll have found the same, like people will want to hear from you and stuff like that. And I think that's what's great about YouTube, is that it allows people to connect that have an interest in similar topics and stuff like that. And that's what I love about it.
Yeah, no, it's awesome. And it's so cool to network with people around the world, you know, in our little online community. I mean, it's look at what we're doing right here. We're not exactly down the street from each other.
No, exactly. But yeah, it's nice when you like, I get sent pictures of the sky from all across the world, which is amazing. Like, if there's been like, you know, the moon pairing up with Venus or something like that, like people will send it me and they'll be like, oh, this was taken in Perth in Australia, or this was taken, you know, like out on the outskirts of Mumbai in India, or like this was taken, you know, in Anchorage in Alaska or something like that. You know, it's just from so like different far-flung corners of the world. And it's just amazing to think that there's all those people around the world coming together and being able to see the same thing as well, which is kind of awesome.
Well, and something that I've been trying to, promote more on my channel is women in STEM. And, that can be really hard to find. So tell me about, how that, if that has been something that you've observed, that you're kind of the minority in your field, or just growing up, being interested in science and math. And as a girl, was that unique? And how do you think that we can get more women interested in this?
Sure. Yeah. So, I mean, I went to an all girls school. So I was lucky in the fact that I didn't have this, like, this is what boys do, this is what girls do. I almost had, this is what the cool girls do, and this is what the not cool girls do. But like, I was lucky in that fact that I didn't have that. And I didn't really appreciate the disparity between the number of women and the number of men studying physics until I got to university. And it was perhaps a gender split of about 85 to 15, in terms of percentage, between 85% male and 50% female, 15% female. So that was when I noticed that it was quite low. Astronomy and astrophysics as a whole is quite higher in terms of the proportion of women in research positions compared to physics as a whole, which obviously says we're doing something better. I have never felt like I wasn't welcome in astronomy. I've always felt welcome, and the women and men who I've always worked with are very supportive of each other, and it's a lovely community to be a part of. I think there is definitely, though, this problem, and it's not just something that affects STEM. And I think that's the problem, is that people have come in with this is a problem in STEM that needs to be fixed, and it's not. It's a problem across all subjects. So the Institute of Physics in the UK did a study about when do you need to go into schools to prevent this, like, physics is a boys subject and it's not a girls subject, or whatever, that sort of approach, thinking that it needs to be around 14 when kids are picking their what we call our GCSEs in the UK. So, like, narrowing it down to 10 subjects. But that's too late, they figured out. So they thought, okay, well, maybe it's at 12, just after they start high school or middle school, I guess, in the US. And then, no, that's too late still. And they realized you have to go in at 7 years old is when you have to go in to kids. And that's the point at which this idea of that's a boy's toy and that's a girl's toy comes ingrained in kids' brains, either from other kids or from their teachers or from their families, whatever it is. There's this societal view that's placed on the different genders, that's like, boys will be boys and they can run around and be boisterous, but little girls, their worth is in how they look and how they sound, and whether they're cute and whatever. And that's when that gets ingrained in kids, and it leads to this huge disparity in the subjects later on when people are studying them at like a later level. So in A levels in the UK, which is like 17 and 18, you pick 4 subjects. If you look at the gender split across that, there's very few girls doing physics, computer science, math, stuff like that. But there's also very few boys doing stuff like psychology and nursing and English and drama, the things that are then suppressed in boys. They're not allowed to, express their feelings or show effeminate, whatever it might be. So you need to address that as a whole to fix the problem that we have in STEM necessarily.
Right.
Or at least in the STE part of STEM, because I think medicine is in its whole other category.
Right.
Because with medicine, there's this nurturing aspect. So women have always been encouraged, if they were into science, to go into medicine because that somehow fits, with the gender sort of societal norms and stuff. So I found that study really interesting that they did, basically concluding this is not a problem for physics. It's not a problem for STEM. It's a problem for us as a whole to stop putting unrealistic expectations on kids when they're 7 years old for, what they're, how they should identify or whatever.
Wow.
So.
No, that's a great answer. And looking at your channel, of course, as a journalist, I had to do my homework. Your most popular video is your, day in a life. Was that surprising to you?
It was surprising how well it did, and the fact that it is my most popular. I made it not in a calculated way. That sounds like I'm like very manipulative, but it's like I think it was like almost like a good business decision. I don't know what you would call it, but I was very aware that the YouTube algorithm, while great in allowing people to find content, has some issues when it comes to women in STEM. So you are recommended videos based on your age, your gender, and your location. So like, what have other people of your age, gender, and location been watching? And so that's one aspect of the YouTube algorithm. But then if you consider the fact that of the top 20 science channels on YouTube, only one is fronted by a woman, which is Simone Yates, queen of shitty robots. She is awesome. And then also the stat that more male-led channels are more likely to be watched by men, and female-led channels are more likely to be watched by women. You end up with this loop of a very circular thing where men are disproportionately recommended science videos on YouTube. And it's not that we don't want them there. We like, come talk science with us. That's great. But what we don't want is women or young girls to be excluded from being recommended that content just because of their gender, right? And because other kids of their gender in their location have not watched those kind of videos. And so what I tried to do was sort of like, get around the YouTube, like use it, but in a different way, was sort of do what I call like crossover videos from the science field into a trending topic or whatever it might be. So day in the life is a massive one, especially for university students and stuff like that, because they want to see what people's jobs are like. And if you look at the stats on that video, it's almost 50-50 a gender split. Wow. But normally my gender split is like 85-15 again, if I'm looking right. So like you can see that it does work in getting, that content in front of more girls. Right. And then also like meme reviews and stuff like this, right? And then like reaction videos to various different sci-fi. These are the kind of videos that I make where people aren't expecting to learn anything about science. They click on it for the humor. And then it's like you hit them with science anyway. You almost like trick them into learning something. So you've got to be a little bit clever with what you do. And so on my channel, I've always tried to make videos across like a breadth of stuff, from someone who's never thought to watch a science video before can find something to watch that they will engage with and understand, to someone who's like super invested, has probably done physics to a certain level and like wants to know like the cutting edge of what's going on in terms of research. Like you've got videos for them too, and you have everything like in between. Right. And that's always what I've tried to do. So there's like something for everybody.
No, it's so smart, and it makes sense. And I think that is not manipulative. That's, a great strategy, like you're saying, to get,
strategy, good word.
Yeah. Both sides involved. I mean, I myself, I have, like 97-98% male demographic.
Yeah. And it's not that we don't want them there. Like, please, like, come and speak science with us. Of course we just also want like some women as well, because we don't want them to be excluded from the conversation. If they don't want to be there, great, but like we don't want them to not even be recommended something because they've assumed that you don't want to see it. Right.
If they're not even exposed to it, they're not going to know. And I love that you do, you've done kind of a reaction to Don't Look Up and The Expanse. I loved that show. And so I think that's great, because I think that as we do watch TV like that, it's like, is this accurate? How much of this is actually realistic?
Yeah. And I think there's part of that where it's not like, I'm not trying to like bash any of the producers or the script writers or whatever for those kind of shows, because it is science fiction.
Right.
Like, you need plot, you need something that is different or whatever. Is fictional science. But I think people are naturally curious when they watch that stuff, whether that is something that we can do currently or trying to do or something like that, or whether it does just break the laws of physics entirely. Because if you don't have that background knowledge, you don't know, and then the lines between science and science fiction get blurred. So those reaction videos are more kind of like, again, it's like you think you're gonna get humor, but you're gonna get science, right? You're gonna get like tricked into learning something, and sort of so that those lines are not as blurred, right? So at what point the line has been crossed into fiction.
Right. And just reading your comments, people are so grateful and say, hey, you've explained this so well, and it's not intimidating. And so you do a great job.
No, thanks. Yeah, it's fun. I guess like I've spent too many nights in the pub with mates that are just generally interested in hearing more about space, that I'm just like, let's just go with that vibe. Let's pretend that we're just sat in a pub or a cafe or something having a chat. And I've never been able to do the very like scripted, like and subscribe. Like I just find it so awkward that I'm just like, no, we're just having a chat. Who was I speaking to? can't remember who it was, but they were saying like, how do you like script your videos? I was like, I don't. I just
Yeah.
take notes and then I just chat. Like, do
Yeah.
you am I supposed to write a script? Like,
Yeah.
like that was really odd to me. It's like the different ways that people go about,
Yeah.
producing their content and stuff like that. And it
It's,
does mean that occasionally mistakes creep in because I'm just like chat, like, yeah, whatever, stuff like that. And then I don't catch it in the edit, but I'll always correct myself in the comments for people who pick it up. People
right.
will keep me on my toes. So.
Oh yeah. No, they're really good at noticing any little error. I find I've been a TV news reporter and anchor for the past 8 years. And so when
Wow.
you start out, you have like a script memorized word for word because you're so nervous you're going to mess it up. And then as you evolve, you have bullet points. But I think the sign of a really good reporter is being able to just casually, explain and not worry so much about every single word having to be perfect. So I think that kind of idea of bullet points is great.
It's how I do my research, to be honest, as well. Like we'll get a result, and instead of writing, like I can't sprout beautiful scientific prose like some of my colleagues can. They can write, in scientific language just straight off the bat down onto a page. And
Right.
I've always struggled with writing. I've always thought I wasn't good at it because my English teacher told me I wasn't good at it. Turns out if you're writing about something you actually like, and not just Of Mice and Men, having read it for the 10th time, like you can actually write all right. And but I still can't do the scientific prose. So like we'll have, we'll get some results, some plot. I'll put it in the paper and whatever in the document that we're writing, but then I'll just like bullet point, like this means this means that, blah, 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 blah. Like very much kind of like casual, almost like word vomit down onto a page. And then like I'll go through and like actually write it properly because I just can't, just sprout scientific prose.
Right.
So.
I'm curious because when I was in school and when I was learning to write, I think that my biggest struggle was being too long-winded and then having some things that almost weren't like in the right order. So what did you struggle with specifically with writing?
It wasn't like order or structure. I could always write like a plan of an essay or a plan of a research paper or something like that. But it was just staring at that blinking cursor of a blank page, I find is excruciating.
Yeah.
And I just have to put anything, even if I'm just like, I am so bored today, blah, 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 like whatever. Then I start thinking like, oh, I'm literally writing whatever like train of thought I'm having. And eventually it gets me round and you just don't have a blank page. That's always the thing that I've really struggled with is the blank page. So it takes me a while to actually write some scientific papers.
So are you ready for the speed round of questions?
Sure. Yeah.
All right. So you can answer these at, however thoroughly you would like to, or we can just, because
no explanation.
I like the lightning round. Yeah. So who is your biggest role model?
Jocelyn Bell Burnell. She discovered pulsars and in the 60s when women weren't as high a percentage in astronomy as they are now. And she's still working in astronomy and she's a massive advocate for minorities and women in astronomy. And I think she's fantastic.
What is your best advice to young people?
Make decisions for you, not for anybody else. Always do what you love and chase your dream, and learn to code because there's so many fields that and jobs that now rely on people knowing how to code.
If you had your choice and unlimited, resources to study something, what telescope would you choose and what would you choose to study?
So right now, I would love to use the Muse instrument on the Very Large Telescope in Chile. That would allow me to get the super detailed information I need on my galaxies to study black hole growth. However, the James Webb Space Telescope is now in space. And I'm very excited for the first results that are going to come down in terms of the first black holes to form in the universe. So whether stars form first and then a black hole forms when one of those stars dies, or whether gas can directly collapse into a black hole in the early universe. And hopefully James Webb being able to see as far as it can, because it can detect infrared light that has been redshifted out of, say, the range of the Hubble Space Telescope, it should be able to tell us which is which. And I am very excited for that.
Absolutely. What is your favorite sci-fi show and author?
Ooh, so author, either Brandon Sanderson or Pierce Brown. Brandon Sanderson's more of a fantasy sci-fi rather than just sci-fi, but he was great. Red Rising by Pierce Brown is one of my favorite sci-fi novels. Show, don't watch a lot of sci-fi TV because I don't have a lot of time. But I did love The Martian. The Martian is one of my favorite films in terms of sci-fi. I thought it was great.
Okay, I need to see that because you were not the first person. Actually, Scott Manley, I just interviewed him. I know, what is wrong with me, right? I just went, you know who Scott Manley is, right?
Yeah.
So I just went to his house to do an interview with him. I know. And he said he loved The Martian. So now it's official. I need to watch it.
You gotta do it.
Oh yeah. Are we alone?
No.
I love it.
They've not visited us here. Like
right.
UFOs unidentified is the key thing there. There's a lot of stuff we don't know that I don't think they're like flying saucers or anything, but like the scale of the universe, the numbers involved, we are not alone.
All right. A follow-up to that. We're not alone, but how likely is it that we're going to ever make contact with they?
Incredibly unlikely, unless there is life on Proxima Centauri B, one of the planets going around the closest star to us. I doubt we will ever make contact, because I think one thing that people don't think of is the timescales for civilizations. Like, think how long humans have been around, like what, a couple 100,000 years, that, and think about that in terms of the 14 billion years that the universe has been around for, right, and how long it took for that life and civilizations to come around. Like, I think in terms of like, civilization could have come and gone like hundreds, thousands of times already in the universe, and we wouldn't know.
That just blows my mind.
Yeah.
It's crazy. And it also makes me wonder, could they perhaps have way more advanced technology that they could get to us, in a way that we just don't know about, or are they in a different dimension?
I think it's more likely that they have different technology that we don't know about, different dimensions. Not so much. I don't think you could get life in a different dimension. So,
outside of space and research, what does Dr. Becky like to do?
I like to go on hikes a lot. And I'm I just love the ocean. So anything to do with scuba diving or swimming or snorkeling or being on a boat, anything like that, like that's where you'll find me. And then also I love to ski as well. And I was hoping to get skiing this winter, but I don't think COVID's going to make that possible. So we'll see.
Well, here in Salt Lake City, Utah, we have some of the best skiing in the world. Mm-hmm. So have you ever skied here?
No, I've only ever skied in the Alps in Europe. So like France, Italy, Switzerland, that kind of thing. But I really want to, like, my friend keeps telling me about, so there's a big conference, there's a big conference that will happen, that are like big astrophysics conferences, but they're in ski resorts. So like you conference from like 7 a.m. to like 10, 11 a.m. and then you go skiing for a few hours and then you come back and you finish the day's conference.
Wow.
So ski lifts are shut at 4. So like they do that like in the Alps, but there's also one in Boulder in Colorado because there's a big astro department as well in Boulder. So I would keep wanting to go there for either that conference or just the ski, but maybe I'll have to try Utah as well.
Heck yeah. No, that's awesome. Do you play music? You have some instruments. Yeah.
They're ukuleles. People always think they're guitars and the perspective plays with people's head, but they're small ukuleles.
They're small.
I play some uke a little bit, like it's fine. And I'm mostly a piano player, but my piano is currently at my parents' house because it doesn't fit in my house. So I don't get to play it as often as I'd like.
Do you have pets?
No, because we moved into this house and we're like, we want to travel, so we don't want to get pets. And then COVID hit. So we're still waiting for able to travel, and then maybe one day we'll get some pets. But I did have cats growing up. I'm a big cat person, which doesn't mean I hate dogs. I love dogs. I just like cats.
I'm in the same boat. I'm like, cats are a lot easier to manage, especially if you do leave the house often. Mm-hmm. I feel like a lot of people on my channel ask if I'm married. Do you get that question all the time?
Yeah, I actually put marry and babies in kitchen in my filtered words. So I never see any of those comments. And
Oh,
nobody ever sees them.
that's
Because
smart.
it was just so often, but also I didn't want young like girls or boys scrolling to my comments and just seeing a load of marriage proposals, because it like, or asking if I was married, because it just reduces the role model to their marital status, which you don't always want, right? Anyway, I'm not married, but me and my partner have been together for about 15 years. So.
Oh, 15?
Mhm.
Wow, that's amazing. And you said one of the words you filtered is kitchen?
Yeah, like, what are you doing doing science? Get back in the kitchen.
I've had a couple of that, but that is so smart and also so sad.
Yeah. Although my response to it is like, I'll go back in the kitchen, but I'll just keep doing science with better access to snacks. Like,
I love it. I love you're sassy. I love it. Yeah, is there anything else that I missed? I appreciate you, spending this time. My viewers are gonna just eat this up. But is there anything else I missed that you just want to tell people, or maybe, what you're most excited about? I mean, obviously web is exciting, but
yeah, I'm really excited for web. We haven't talked about Starlink, which is what I thought you were going to ask me about.
really? Okay,
Yeah.
let's talk about it. I'm all about that.
Yeah, I know. I mean, I'm very much in favor of what Starlink is trying to do, like providing internet for people all around the world, wherever they are. That's a fantastic like thing to strive for, is like equality in that sense. But I think not enough thought has been put into how it will affect astronomy on the ground. I think there's just this dismissal of it should be done in space anyway. But so much is still done from the ground, because doing astronomy from space is, not just expensive, but also difficult. If stuff breaks down, you can't necessarily service it for where you need the telescopes to be. There's so much more that happens from the ground. And what I don't think people realize is it's not just the optical, the visible light with stuff streaking overhead, but radio telescopes. Radio telescopes are so sensitive that if you come within like a mile of them, like please turn off your mobile phone signals, because they're that sensitive. So I've seen colleagues who work in like radio astronomers, where a satellite's gone overhead when they're taking some data with a big radio dish, something like Arecibo, in Puerto Rico that recently collapsed or whatever. And there's just this huge, big interference spike from the fact that the satellite is obviously communicating with the ground with radio. And so there's so much that's done with radio telescope that's done like in huge surveys, where they have a bigger field of view. Radio telescopes, they see more of the sky at once. And so these satellites are a huge impact on them. So I think there's more that can be done, not just like painting the satellites black or whatever, like stupid things that were like recommended or whatever, but like actually like sharing the positions of the satellites. Because, if you're doing if I'm doing sort of like an exposure on taking data with my telescope, I'll do like a 10 to 20 minute exposure, and I'll do that like 6 times and add them all up to give me like a 2-hour exposure, right, of this one galaxy. If a satellite streaks across one of those, that makes 20 minutes unusable, right? That's
right.
A good chunk of my data that's unusable. But if I know there's a little alert pops up that's like, oh, satellite about to pass overhead, like Starlink, I'll be like, oh, okay, I'll stop that read and I'll save the first 5 minutes, and then I'll wait a minute for it to go over, and then I'll start it again. Like that kind of communication would be great to make both things possible,
Right.
So and I think that's what can be done. I think people don't realize that the huge impact it could have, not just on visible, but on all areas of astronomy.
Well, I do hear that a lot, just do that research in space. And in talking to Harvard astronomer Jonathan McDowell, who's my friend, he explained that there's a lot of, stuff on the ground that it needs to stay on the ground, and it's, but people, but the backseat drivers or whatever, just do it this way. Duh.
Yeah. Like, no, we thought it's this, but I think that's the way forward. It's just communication between the two fields, right? And I get why companies might not want to share the exact locations of satellites and whatever, but I think that might be one way at least to solve this issue. And like Jonathan said, like radio telescopes are these huge arrays on the ground, right? We're literally building a kilometer square array at the minute, which is like antennas across a square kilometer. You can't put that in space necessarily. They have to stay on the ground. But also like the Large Synoptic Survey Telescope, LSST. It's recently been renamed the Vera Rubin Observatory after Vera Rubin, who first evidence for dark matter. And like that is basically looking for stuff that changes in the sky each night. And like first numbers that have been run in terms of like asteroids, comets, maybe supernova going off, variable stars, all this kind of stuff. That's going to be 1 million alerts a night for stuff that changes if you then add like how many tens of thousands of these constellation satellites in there as well, like how much that's going to be such a like a bore just trawling through that data to remove them to get at the stuff that we actually care about, the scientific stuff. Like when you've already got a million to deal with anyway, like it's a huge deal. And machine learning algorithms to pick out this stuff are coming along, but they're still not perfect and everything. And it's all the stuff that we could miss because we don't know to look for it, or it might have been thrown out because a satellite went across, big satellite constellation. So you just don't know, right? And I think it'd be cool if this could happen, but I think more thought needs put into it soon. It's amazing to me that like space lawyers exist. Like I never knew this, right? And who has the right to space, who you know is responsible for cleanup, and who is liable for these kind of damages or whatever. Like, you know, if some research is damaged because of this, is that do you owe some sort of compensation to the researcher because your tech got in the way of their observations? Like it's really interesting sort of from a legal and business standpoint as well. Like when you think about this stuff, there's so many areas that I think people have gone, whoa, what about this? You know?
Right. Well, and I think it's just going to become kind of a growing industry or even problem, as you know, it's not just Starlink. And
oh yeah, 100%. I think it's the one that's most famous, obviously, but Amazon's in this and everything as well. So
and the constellation is still growing. I mean, we're not even anywhere near what it's going to be. You know, so yikes, maybe.
Yeah, but it's already a little bit of an issue. Yeah, and there's going to be what, like 3 or 4 of them up there. So.
Yeah, but also, you know, conquering the digital divide. I mean, that's really important too. So it's
as I said, 100%, and it's a great like goal that they're aiming for. And obviously the other thing is like, is, you know, just space junk as well. Like if there's any issues with one of these satellites, it can cause a cascade that could affect or other satellites in nearby orbits as well, and that kind of damage to other satellites. It's sort of cool.
Kessler syndrome, a big concern, but I do think that there are, you know, evolving companies that are trying to figure out how to clean up the space junk. So
yeah, it's great to see.
It's good timing, right? Yeah, man, I just feel like I could ask you a million questions, but I know that you probably have stuff to do today. So
I've got to get on with, I'm actually writing a paper at the minute, and that blinking cursor.
Oh my gosh, no.
So, sorry, I'm going to procrastinate that a little bit by making these plots like finalized to put them in, and then I'll, you know, do my little word vomit bullet point thing, and then we'll make progress.
This is random, but have you ever watched that episode of SpongeBob where he's like trying to write a paper, and he's like, there's this exaggerated scene where he's just like furiously scribbling in this like the word is yeah, that's what you're making me think of.
So much SpongeBob as a kid, the amount of SpongeBob references we end up making, and I know exactly which bit you're talking about.
Yes, it made an impact. They did a great job. I'll never forget that.
They really won't.
Patrick, your genius is showing, right?
Yeah.
No, I love
every time we go for a pizza, we sing Krusty Krab pizza.
Yes, yes, I love
every
it.
Time.
I love it. It's an important show to watch, you know. People
really
should get a little SpongeBob in their life. Well, Dr. Becky, thank you so much. Honestly, this has just been awesome to hear from you. You're so easy to talk to and such a delight.
Thanks.
Yeah.
Like I said, the only issue that I had with this video is that I didn't have enough time to spend with Dr. Becky. She was such a delight to talk to, and I'm really grateful for us being able to coordinate our time zones to make this interview work. So if you enjoyed the video, please make sure to like and subscribe to Ellie in Space if you're not already. And if you really enjoyed the video, please consider sharing the video with your friends. All of the support means so much, especially thank you to my Patreon subscribers. Your support is allowing me to do a lot of really cool things this year, including some awesome trips that I have planned, and you won't want to miss it. So stay tuned for that, and I'll see you soon.